In section 6.5, we're going to be talking about conditions for special parallelograms. So, why do we use this? Because building contractors and carpenters can use the conditions for rectangles to make sure the frame for the house has a correct shape. So, when you are given a parallelogram with certain properties, you can determine whether the parallelogram is a rectangle by using the theorems. So by using these two theorems here, we can prove something is a rectangle. So let's look at this. Now notice that both of these start off with the hypothesis that we have a parallelogram. That's important. So you have to know first that it's a parallelogram, not that it's a quadrilateral. So if you have a parallelogram and you have one right angle, then that's a rectangle. If you have a parallelogram with diagonals that are congruent, then it's a rectangle. Example 1. If a contractor built a wood frame for the side of a house so that segments XY and WZ were congruent and segments XW and YZ were congruent, using a tape measure, the contractor found that the length of XZ is equal to the length of XY. Why must the frame be a rectangle? Well, here's the reason why. Both pairs of opposite sides of WXYZ are congruent. So WXYZ is a parallelogram. I want to make note of this. If you only told me that the diagonals are congruent and that was a rectangle, that would not be correct. You first have to know it's a parallelogram. I want you to make a note of that. Make sure you write that down and put a star next to it. You have to make sure it's a parallelogram first. So since opposite sides are congruent, we then can say that it's a parallelogram. Now that we know it's a parallelogram, and now we know the diagonals of parallelogram WXYZ are congruent, then we can say that the frame is a rectangle. Now below are some conditions you can use to determine whether a parallelogram is a rhombus. So the last two are proving that it's a rectangle. Here we can prove if it's a rhombus. Once again, you'll notice that we all have to know that they're all parallelograms to begin with. So if we know a parallelogram, if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So notice here that two consecutive sides are congruent, therefore it's a rhombus. If the diagonals of a parallelogram are perpendicular, then it's a rhombus. And if one diagonal of a parallelogram bisects a pair of opposite angles, then it's a rhombus. So all three of these ways would prove that a parallelogram, not a quadrilateral, a parallelogram is a rhombus. Now I want you to make note of this. To prove that a quadrilateral is a square, it is sufficient to show that the figure is both a rectangle and a rhombus. So if you can use one of the two conditions for a rectangle and one of the three conditions for a rhombus, then you can use that to prove that it is a square. You will explain why this is true in exercise 43. All right, example 2. Applying the conditions for special parallelograms. So here's what we want to do. We want to determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. So here's what we know. Segment AB is congruent to segment CD. Segment BC is congruent to segment AD. And segment AD is perpendicular to segment DC. We also know AC is perpendicular to BD. Now step 1. Step 1 will always be to prove that it's a parallelogram. Well, what do we know? Can we prove this is a parallelogram? Well, we know AB and CD are congruent. We know BC and AD are congruent. Step 1, quadrilateral with opposite sides are congruent. If we have that, then it's a parallelogram. So step 1, we proved that it's a parallelogram. Step 2, since we want to prove it's a square, we have to prove that it's a rectangle. Well, we know AD is perpendicular to DC and AC is perpendicular to BD. Well, because of this statement here, segments AD and DC are perpendicular, that leads us to step 2. Since we know that segments AD and DC form a right angle, Then we know that ABCD is a rectangle. So because of definition of perpendicular, we know it's a right angle, and because the parallelogram has a right angle, one right angle, it's a rectangle. So now we can go further. Now we have to prove it's a rhombus. So step 3, let's prove it's a rhombus. Well, because we know segments AC and BD, which are the diagonals, since they're perpendicular, parallelograms with diagonals that are perpendicular form a rhombus, so therefore we know it's a rhombus. So finally, to determine if it's a square, since ABCD is a rectangle and a rhombus, that means it has 4 right angles and 4 congruent sides. That's why we did that. A rectangle says we have 4 right angles. A rhombus says we have 4 congruent sides. So put together, we know that ABCD is square by definition, and therefore the conclusion is valid. So part B, given that segment AB is congruent to segment BC, prove that it's a rhombus. So just because I know segments AB is congruent to segment BC, can I prove it's a rhombus? Well, if you look at the conditions of a rhombus, the conditions of a rhombus say that if you have one pair of consecutive sides congruent, then it's a rhombus. Is that true? Look at what you wrote down. Is it true? Hopefully you say no. And the reason is this. The conclusion is not valid. Now, by that theorem, and I never want you to actually know the theorem number, but by that theorem, one pair of consecutive sides of a parallelogram are congruent. Then the parallelogram is a rhombus. The problem is that you must first know that it's a parallelogram. We don't know this is a parallelogram. Therefore, we cannot prove this is a rhombus. The conclusion is not valid. All right, example 3. Use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or a square. Give all the names that apply. So in part A, you're given 4 points. So the first thing we need to do is graph them. So here's our graph. We have quadrilateral, ABCD, and we know it's a parallelogram. We have to determine if it's a rectangle, rhombus, or square. So by using the diagonals, remember, we have to use the diagonals. And just because we can look at this and say it's not a rectangle, we have to prove it. So we have to find the lengths of AC and BD. So the lengths of AC, let's see, if we subtract our x's, it'd be 8 squared. Plus subtract 6 minus 2, that gives me 4 squared. That would give me, the square root is 64 plus 16, which gives me the square root of 80, which simplified would give me 4 times the square root of 5. Now BD, subtract my x's, 3 minus 5 is negative 2 squared, plus 6 minus 2 is 4 squared. That would give me 4 plus 16, which gives me the square root of 20, which gives me 2 root 5. Now we know that these diagonals are not equal, so not a rectangle. But now we have to prove it's a rhombus. And now we automatically know it's not a square either, because in order to be a square, we have to prove it's a rectangle. So now we have to prove it's a rhombus. Well, what do we know about the diagonals of a rhombus? We know the diagonals of the rhombus form a 90-degree angle. They're perpendicular. So now we have to find the slope. So the slope of AC, if we did that, we could subtract y, that'd be 4 over 8, which would be 1/2. The slope of segment BD would be 6 minus 2, that'd be 4 over 3 minus 5, which is negative 2. That gives me negative 2. Because 1/2 and negative 2 are opposite reciprocals, and their product is negative 1, we know that ABCD is a rhombus. So the same thing is true here. Use the diagonals to prove what this is. So the first thing we have to do are find the lengths of the diagonals. And in this case, the diagonals are EG and FH. So let's do that. EG would be, let's see, 0 minus negative 1, which would be 1 squared, plus 3 minus negative 4, which is 7 squared. That gives me 49 plus 1, which would be square root of 50, which would simplify into 5 root 2. So 5 square root of 2 would be the length of EG. FH would be, let's see, negative 3 minus 2 would be negative 5 squared, that would be 25. 2 minus negative 3, which would be 5 squared, which is also 25, which would give me the square root of 50, which is also 5 root 2. Well, because 5 root 2 equals 5 root 2, we know that this is a rectangle. Okay, now we're going to look at the slopes. So the slope of EG looks like it is going to be up 1, 2, 3, 4, 5, 6, 7. So the slope is 1/7. The slope of segment FH, down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 would be negative 1. So the slope is negative 1. So we know that 1/7 is not the opposite reciprocal of negative 1. Therefore, they are not perpendicular. So it cannot be a square, so my answer would be a rectangle.